the given question here is, the function here is x square plus 2x plus 5 divided by x cube plus 2x plus 4. Okay. Now this is a quotient of two functions. So if I take u is equal to x square plus 2x, that is the numerator, I take as x square plus 2x plus 5. And if I take the denominator as v, x cube plus 2x plus 4. Therefore, y becomes u by v, right? That means, what is the quotient rule for differentiation? It is v du dx minus u dv dx whole divided by v square. This is the quotient rule for differentiation. Let's put the values here. That means dy dx is v is x cube plus 2x plus 4 into ddx of u or du dx, which is x square plus 2x plus 5 minus u is x square plus 2x plus 5 into the ddx of v or dv dx, which is x cube plus 2x plus 4. And this entire thing must be divided by the square of the denominator, that is v square. So you have x cube plus 2x plus 4 square. Okay. Now in the numerator, we are going to carry out the differentiation as usual. Okay. So you have x cube plus 2x plus 4 as it is. And here we are going to distribute the operator ddx over the entire polynomial. So ddx x square plus ddx 2x, but 2 is a constant. You can take this out of the differentiation, 2 ddx of x. I hope I can skip this method of writing ddx 2x, right?
Yes, sir.
Plus ddx 5, right? And this is minus x square plus 2x plus 5. Again here you can distribute this operator over the entire polynomial. So ddx x cube plus twice ddx x plus ddx 4. And this entire thing divided by x cube plus 2x plus 4 square. So you have x cube plus 2x plus 4. ddx of x square here, that's the within the box brackets, you see ddx x square here is 2x plus twice ddx x. That means 2 into 1, which is simply 2. And this is equal to 0, right? So this is simply 2x plus 2 minus x square plus 2x plus 5. Again, within the box brackets, you have ddx x cube first. ddx x cube is 3x to the power of 3 minus 1. That means 3x square. Plus twice ddx x. Twice ddx x is simply 1. So 2 into 1 means 2. And ddx 4. 4 is a constant, differentiation is 0. Divided by x cube plus 2x plus 4 square. Okay. So now here we would like to multiply everything and then express the answer in a proper manner. Okay, so how do you multiply here? see that you are getting x square plus 2x plus 4 here and x square plus 2x plus 5 here, right? So what you can do here is you can multiply directly. So you have 2x to the power of 4 plus 2x cube plus 4x square plus 4x plus 8x plus 8 minus, and here you have 3x to the power of 4 plus 2x square plus 6x cube plus 4x plus 15x square plus 10. And this entire thing divided by x cube plus 2x plus 4 square, which is equal to, now you simplify the first part, you have 2x to the power of 4 plus 2x cube plus 4x square, and you have 4x plus 8x, which is 12x, right? Plus 8 minus, and here you have um, 3x to the power of 4. Anything that needs to be simplified here? No, nothing needs to be simplified. So yes, there is one. There are two squares. So we first add them. 3x to the power of 4 plus 6x cube is there. And then you have
Yes.
square, 2x square plus 15x square, which is 17x square, right? And then you have a 4x plus 10, whole divided by x cube plus 2x plus 4 square. Now you can open the brackets and change the sign. So you have 2x to the power of 4 plus 2x cube plus 4x square plus 12x plus 8 minus 3x to the power of 4 minus 6x cube minus 17x square minus 4x minus 10 divided by x cube plus 2x plus 4 square. Now you have 2x to the power of 4 minus 3x to the power of 4 will give you minus x to the power of 4. In terms of x cube, you have 2x cube minus 6x cube, which will give you minus 4x cube. You have 4x square minus 17x square. So 4 minus 17 is minus 13. So minus 13x square. You have 12x minus 4x, which is 8x. And you have 8 minus 10, which is minus 2. Divided by x cube plus 2x plus 4 square. And now you can take negative sign out. And write this as right. So this is how you apply the UV rule. The later part is only simplification, but the actual differentiation ends here. Okay. Any question?
No, sir.
We'll move ahead with the next problem. UV rule and U by V rule are very important, so please practice them well. Okay. Look at one part 4. You have given function as t square into t plus 1 to the power of minus 1. Okay. Now the variable here is t. Okay. If I say let v is equal to t square into, you can take y also, no problem. T plus 1 to the power of minus 1. Okay. I've taken v because normally t is taken as a time, and v is considered to be velocity. Okay, in physics. So that is why I've taken this as v. So let v is equal to this. That means you can write this as t square by t plus 1, right? You need to find dv dt, that is the differentiation of v with respect to t, because the variable here is t. So therefore dv dt is equal to ddt of, now I'm going to use u by v rule directly. Okay? T square by t plus 1. Now if I use u by v rule, if I consider this as u and the denominator as v, what was the rule? V ddt of u, t square, minus u, which is t square, ddt of v, which is t plus 1, divided by the square of the denominator, t plus 1 square. Right? Any question here?
No, sir.
You get t plus 1, and ddt of t square is 2t to the power of 2 minus 1, which is simply 2t, right? Minus t square. And what is the ddt of t plus 1? It is simply 1, isn't it? Because this is of the form ax plus b, isn't it? So this ax plus differentiation of ax plus b was equal to what? Was equal to a, right? So therefore the coefficient of t here is 1. So this will differentiation of this will simply be 1 divided by t plus 1 square. So you get here twice t into t plus 1 minus t square divided by t plus 1 square. So you get 2t square plus 2t minus t square divided by t plus 1 square, which is equal to t square plus 2t divided by t plus 1 square. Now you can take t out, write this as t into t plus 2 by t plus 1. And that is what your differentiation is. You have a square, right? Oh, yeah, fine. I forgot to write the square. You cannot write it in this manner. You had a square in the denominator. You can write this as t into t plus 2 divided by t plus 1 square. Okay? So that should be it. Let us see the next one. The next one is also an application of u by v rule, the quotient rule of differentiation. One part 5. The question is u by u square plus 1. If I take v as u by u square plus 1, then v is a function of u. Therefore, we can differentiate v with respect to u. So therefore, dv du will be equal to ddu of u by u square plus 1. Okay, which is equal to, take the numerator as u and the denominator as v. So the formula was v du dx. V here is u square plus 1 into ddu of u, ddu of the numerator, minus u into ddu of u square plus 1 divided by square of the denominator, u square plus 1 square. Okay. Now this will become u square plus 1. ddu of u is simply 1 minus u into, here ddu of u square, you can distribute this differentiation over this polynomial. So you get ddu u square plus ddu 1 divided by u square plus 1 square. So you get this as u square plus 1 minus u. ddu of u square is 2u to the power of 2 minus 1, simply 2u. And ddu of 1 is 0, where 1 is a constant, divided by u square plus 1 square. So you get here u square plus 1 minus 2u square divided by u square plus 1 square. So getting here 1 minus u square divided by 1 plus u square square. And that's your answer. Any question?
No,
I can
sir.
move to the next one then.
Yes, sir.
We'll do number 2 now. If you see, the question here is if fx is equal to x plus 2 by x minus 2. So given fx is equal to x plus 2 by x minus 2, and it is given that x is not equal to 2. That means the function has a finite value, has a determinate value. Okay. You need to find f dash minus 2. In order to find f dash minus 2, that is a derivative of f at minus 2. That is what you need to find. F dash minus 2 means derivative of f at minus 2. First derivative of f at minus 2. We first need to find f dash x. So therefore, f dash x is equal to the differentiation of this function. Let's write this as fx first. ddx fx, which is equal to ddx x plus 2 by x minus 2. Again, we are going to use u by v rule here to differentiate. So you have denominator v into the ddx of u minus u into the ddx of v divided by square of the denominator x minus 2 whole square, which is equal to x minus 2, and ddx of x plus 2 is 1, right? Because it is a linear polynomial, because the coefficient of x here is 1. So this is simply 1 minus x plus 2. Similarly, for x minus 2, the derivative is also 1 because it's a linear polynomial and the coefficient of x is 1. So I get x minus 2 square. So I simply get here x minus 2 minus x plus 2 divided by x minus 2 square. Simplify the numerator, x minus 2 minus x minus 2 divided by x minus 2 square, which is plus x and minus x will cancel. So you simply get minus 4 by x minus 2 square. This is f dash x, but you are required to find f dashed minus 2. So let's put it. Therefore, f dashed minus 2, f dash x, this is what you have got. So you replace x by minus 2. So minus 4 by minus 2 minus 2 square. So you get minus 4 by minus 4 square, which is simply minus 4 by 16, which is minus 1 by 4. So the derivative of fx at x is equal to minus 2 is minus 1 by 4. Okay. I'll move to the
Yes,
next
sir.
question then.
Yes, sir.
Question number 3. Number 3, interesting question. Given y is equal to x by x plus a, what do you need to prove? To prove x dy dx is equal to y into 1 minus y, right? This is what you have to prove. First, let us find out dy dx. So dy dx is ddx x by x plus a. Again, I can differentiate this by u by v rule. So v into ddx x minus u into ddx, right, divided by square of the denominator x plus a square. So you get here x plus a ddx x is 1 and minus, and ddx x plus a is, this is a linear polynomial. Differentiation of a linear polynomial is simply the coefficient of x, which is 1. So x into 1, which is x, divided by x plus a whole square. So I get here x plus a minus x divided by x plus a whole square. X and x will cancel. So I simply get a by x plus a square, right? Now what do we need to prove? We need to prove x divided dx is equal to y into 1 minus y. So start from the left hand side. Left hand side is x divided dx, and dy dx we have already found. X into dy dx here is a by x plus a square. So you're getting the left hand side as ax by x plus a square. Okay. Now we show that the right hand side is also equal to ax by x plus a square. What is the right hand side? Y into 1 minus y. And what is the value of y here? X by x plus a into 1 minus x by x plus a, right? So you get x by x plus a, and you take the LCM, you get x plus a minus x by x plus a, right? So you get x by x plus a into x plus a minus x by x plus a, right? So this and this cancels. So you get ax by x plus, we're getting x plus a whole square, isn't it? Let's see, y into 1 minus y. Okay. There are two x plus a. So ax into x plus a whole square, because these two multiply will get a square. So what you see here is left hand side is equal to right hand side, and it's proved. Okay. Any question?
No, sir.
Okay. Let's proceed with the next one. This should be the last problem for today. Number 4. Given here is x root 1 plus y plus y root 1 plus x is equal to 0. What do you need to prove? You need to prove that dy dx is equal to minus 1 by 1 plus x square. Now this is actually, if you know a little bit of advanced differentiation, this should not be a problem actually. But since we are just starting differentiation, this is the way we should be proceeding. Okay. So what you do here first is you um, you start with the given function. So we have x root 1 plus y plus y root 1 plus x is equal to 0. Okay, this is what is given. Okay, now you take 1 to the right hand side. So you can write this as x root 1 plus y. Before differentiation, we're going to simplify this a little. Minus y root 1 plus x. Now you square both sides in order to remove the radical. So if you square both sides, you get x root 1 plus y square is equal to um, minus y root 1 plus x square. That means you get x square into 1 plus y, right, is equal to y square into 1 plus x. Okay. Next, you multiply everything, you get x square plus x square y is equal to y square plus y square x. Now you take everything to the left hand side, you get x square minus y square. You take x square and y square together, and you take x square y and y square x together, right? Why did we take them together? We have grouped these terms actually. We want to factorize this. So x square minus y square here, and these two, x plus y into x minus y, this can be written as, and here I can write this as x minus y into x minus y is equal to 0. So now from here I can take x minus y, and I get x plus y plus xy is equal to 0. That means now I factorize this. That means what do I have? Either x minus y is equal to 0, or x plus y plus xy is equal to 0. But x not equal to y, isn't it? But x not equal to y. Because if I have x equal to y, then what will happen? What will happen if x is equal to y? If x is equal to y, then we'll have x root 1 plus x into x root 1 plus x is equal to 0. That means we'll get 2x root 1 plus x is equal to 0. That means either x is equal to 0 or x is equal to minus 1, right? And who said x is equal to minus 1? Or who said x is equal to 0? There is no specified value of x. So why should you take x is equal to 0 or x is equal to minus 1, right? So therefore, x not equal to 0. Therefore, x plus y plus xy must be equal to 0. Now from here you can find out y. So you have x plus y into x plus 1 is equal to 0. That means y is equal to minus x by x plus 1. This is what you are getting as y. Okay. Now, once we get y, what do we have to show here? We need to show dy dx is equal to this. That means we need to differentiate y. That means what should be dy dx? Dy dx must be equal to ddx minus x by x plus 1, right? You can take the negative sign out of the differentiation because this is a minus 1. Minus x means what? Minus 1 into x. And minus 1 can be taken out of the differentiation. Minus ddx of x by x plus 1. Now we can very easily apply our u by v rule. So minus v into ddx of u minus u into ddx of v whole divided by v square, right? So you get minus x plus 1 ddx of x is simply 1, right? Minus x and ddx x plus 1. This is of the form ax plus b, linear polynomial. The differentiation of this will be only the coefficient of x, right? Which is x into 1, which is simply x, divided by x plus 1 square. So you get here, this x and this x is going to cancel. So you are going to get minus 1 by x plus 1 square. This is equal to dy dx. And was this the required proof? Yes. We need to show that dy dx is equal to 1 minus 1 by 1 plus x square. Hence proved. Right? So I'll stop here then.
Yes.